In this video, we are going to work on determining the length of an arc. Okay, we are given a formula here, S equals R theta. One thing that's very important for this formula, and it's the whole reason the formula works, is that theta must be in radians. I need you to bold that, circle it, write it again, write it giant, so you will not forget that that has to be in radians. The reason it has to be in radians is, remember, radians is just how many radii fit. How many of my radius can I put around the circle? That would be that theta. So if I just take that angle and times it by r, because r tells me that's how long each one is, that will actually give me the length s. You don't have to really understand why that's coming about, but it does make a lot of sense on why that would be true if you understand the definition of a radian. So, but to be fair, when I was in your shoes, I had no idea why. I just used it. And sometimes in math, that's kind of how that works, is we just use it and work on it, and eventually the understanding will come in. We need the understanding, especially those of you that are in future STEM careers, because a lot of you guys, there's no solution manual to the real world. When you guys are working in your in your future jobs, you're not going to be able to check answers. You're going to have to come up with ways to rationally think about them. So I'll get off that box of why understanding the context and the content over just how to do it is more important, but sometimes we just go with it. Okay, so I'll get off that box. Okay, assume the orbit of Mercury around the sun is a perfect circle. We know it's not. Okay, Mercury is approximately 36 million miles from the sun. So I drew a picture there. The sun being the middle of the circle, and then the circle around it being the orbit of Mercury. And I put 36 million miles there. In one Earth day, Mercury completes 0.0114 of its total revolution. How many miles does it travel in one Earth day? Okay, so what we're going to do is first, I want to know how far is it all the way around this circle. So I'm going to do 2 pi, and I'm going to multiply it by the radius, which is 36. This tells me that the circumference of that revolution is 72 pi million miles. Not 72 pi miles. That would be crazy. So we have that. We can figure out the miles traveled. Of Mercury in one Earth day, because I can use the same formula, right? Or miles traveled would be the 72 pi. That's my circumference. And I only want one portion of it, right? So 0.0114. And that's going to be million miles. So what we did here, in case you, I kind of passed it pretty quick with this formula, is what I'm doing is, this is my full revolution all the way around. And then they told me that we wanted just the time for this bit of a revolution. That's it, 0.0114. And we don't even care about the mile of the Earth Day thing, because they actually told us that is how much of it went in. That's why we're taking our total distance all the way around, 72 pi, and timesing by that number, because that number will give me that fractional part. Okay, this is roughly 2.57861925. I always write all my numbers out, million miles. It's quite a bit in one day. Okay, that's number one. Number two says, use your answer from part A to determine the radian measure. So we're using S equals R theta, and I have the S. The S is how far it went, so that's this 2.57861925 equals, and I know the radius. The radius is 36, and then theta is going to be in radians. So all I have to do is take both sides and divide by 36. If I do that, I get roughly 0.0716281 radians. Remember, we don't have to put rad if we don't want to. I just like to do it in this first lesson, because we do mix up the degrees and the radians. We got to get used to having that notation. All right, we're going to do one more example in this video. It says, find the arc length of a circle of radius 10. So I'm going to go ahead, I'm going to cheat here. I'm going to just go ahead and copy this and paste it down here, and then erase my 36 million miles. Okay, so find the arc length along a circle of radius 10 units. So this is going to be 10 here, subtended by an angle of 215 degrees. Okay, the first thing I know is that if I'm going to find arc length, okay, arc length is S equals R theta, but theta is in radians. Well, the theta they gave us here is 215 degrees. I need to multiply that by pi over 180 to get its radians. And I did that multiplier there because I know the degrees are going to cancel. So 215 over 180, using my calculator, it becomes 43 over 16 pi. Right? And then I'm going to use the formula to find an arc length, which is S equals R theta. They told me R was 10, and then that the angle that we are going to go through is 43/16 theta. So this is going to end up being, I'm going to use an approximate symbol for S. S is arc length. And if I multiply that out, and I think I did round here, I get 84.43. I may have not. Units. So that's how long, if we go that far, that's how long this side is. We found that unit. Even though it curves, we can find the linear distance.